Hi everyone, this is Vidhyalakshmi YouTube channel. Welcome to our YouTube channel. Myself, Satish Kumar, MSc B.Ed. I am a faculty of chemistry faculty in a part of our Vidhyalakshmi institution. We will discuss about that ionic equilibrium. Ionic equilibrium is one of the lesson in chemistry subject in plus 2 standard. Our students facing so many questions, our students facing so many anxiety from this lesson. But this lesson is very easiest to one. It's a smallest lesson. That smallest lesson we discussed about that easiest manner in this way, easiest way to learn in this board exam for our students. And also the ionic equilibrium. This ionic equilibrium is a very important lesson also. Out of 15 lessons we have in a chemistry subject, so one of the lesson in a 8th lesson, that 8th lesson each and every year, so from 2020 onwards, so now itself, so we have crossed so many exams like March 2020 and instant exam 2020 of July and September, August and May, then July also, now September 2020 itself, around 6 or 5 exams we passed from this new syllabus. So in every exams, so it have only 10 to 15 marks asking from this question, this lessons. So 10 to 15, so 8 இருந்து 10 12 mark இந்த லெசன்ல இருந்து வரும். So அதனால definitely we don't omit this lesson. So we study this lesson. So this lesson is very important to one. You see, so this is the mark analysis, mark percentage, weightage percentage of analysis, unit 8. So that weightage content, unit 8 is a 51% weightage. So you more importance for this lesson. And also we learn easily from 2020 itself, so many question asking from this question, this lesson. It's a very easiest to one, and we discussed about this lesson, ionic equilibrium. Yes, it's a very important lesson also. We learned easiest manner of this lesson. So now we discussed about this ionic equilibrium. So the introduction, some of the important process. What is mean by ionic equilibrium? So ionic equilibrium, ions, that means we know about ions means in a cation and anion. So both of two ions is there in every salt or every electrolyte. So it can be dissociate like positive and negative part of that. So positive and negative part of that, both cations and anions in our body. So we use many liquid items in we eat in day by day. So all the liquid things or all the eatable things, it goes into our human body. So that human body, it can be split into ionic nature. So in medicine also, if we taken some medicine, so that medicine also going to ionic nature of that. That ionic nature means one positive radical like, and another one is a negative radical. So some of the equilibrium, that equilibrium means, next we discuss about equilibrium. What is mean by equilibrium? Equilibrium means in a reaction is going to forward. So for example, you see this is the simple reaction. So this is H3O plus and HCO3 minus. So these two paths is called reactants. Its reactants going to H2CO3. This is a carbonic acid and also production of water. So this is the forward reaction. I mean it's a forward reaction. So this reaction in an arrow mark, it indicate the direction of the arrow mark, it indicate the direction of the reaction. In left part of the reaction is called reactant side, and right part of this reaction is called products. So in a reaction, a reactant, it gives products. So this is the simple chemical reaction. But some of the chemical reaction, it's never give up or it's never back. It never comes to back. It never comes to back. So some reactions you see. Yes. So you see students, so in a single arrow mark, it indicates that it is not giving the reverse reaction. It's not coming to reverse reaction. But such kind of chemical reactions, in a such kind of weak reactions or organic reactions, mostly it's coming back to reverse side. So reverse side means in a reactant it's giving to the product, again where the product is giving to the reactants. So this kind of manner is called equilibrium nature. That equilibrium means it's a dynamic in nature. Dynamic means, so the rate of the forward reaction is equal to the rate of the backward reaction. So both reactions is same rate. So this is called as dynamic in nature, dynamic equilibrium in nature, right? Right. Next, you see, in our human body, we explained, in our human body, we have so many equilibrium in nature. So first we learn about that equilibrium nature. You see, so this is the carbonic acid. You know, everyone you know that carbonic acid. So in our body contains acids and base. So carbonic acid. I say one example from in Tamil, Tambulam. That's Tambulam. You know what Tambulam? Vettala, Paku, Sunnambu. So we finished every feast. After the feast, we ate some that Tambulam. So the Tambulam can have in acid and also base. So both two kind of ingredients is there. So that ingredients, it's maintain the digestion factor, it maintains the pH factor, it maintains the acid levels in our human body. So that's why in ancient days we are using that. But now itself we are using Digin or milk of magnesium, magnesium hydroxide, aluminum hydroxide, like that. So in our human body, we consume oxygen and we exhale carbon dioxide. That carbon dioxide is dissolved in our water molecules, it change into carbonic acid, like that. So that carbonic acid, you see, carbonic acid, it's split into bicarbonate ions and hydrogen ions. I mean hydronium ions. This is for hydronium ions. So these hydronium and bicarbonate ions, it's giving to carbonic acid. The carbonic acid automatically dissociate, it's giving to bicarbonate and hydronium ions itself. Right. So this is it's happened in our human body. Next, you see, in this unit, we shall learn the definitions of acids and base and study their ionization and aqueous solution. We learn the pH scale and also apply the principles of chemical equilibrium, determine the concentration of the species, furnished aqueous solution by acid or base. You see, students, acid and base. What is the meaning of acid? The term acid, it comes derived from the Latin word acitus. It's a sour taste. It's a sour taste. That means, so the acitus word, the acid is derived from the acitus word. That means sour. We have already learned that earlier classes, acid, what's the meaning of acid and what's the meaning of bases. Simply we say acid, so H plus ions. So whichever the acid, it produced H plus ions, or whichever the component, it produced OH minus ions. So that is meant by H plus ions. So some components, it produces H plus ions, that is called as acids, and OH minus ions, it's called bases. Right. Let us learn the concept developed by. So acid base concepts. We have three kind of acid base concepts. So that concept is, first one is Arrhenius concept and Bronsted concept and Lowry and Bronsted concept, and another one is a Lewis concept. Okay. Now you see Arrhenius concept. Arrhenius concept. What is the meaning of Arrhenius concept? Arrhenius concept, that is meant by dissociation concept. If any of the salt, you see any of the salt, the HCl or any of the solutions like sodium chloride, NaCl or anyone. So any of the component, or so HCl, it is dissolved in water molecule. The hydrochloric acid or sodium hydroxide or whatever may be, some salts, it is dissolved in water molecules, it produces H plus ions. It produces H plus ions. You see, it produces H plus ions. Yes, H plus ions. That H plus ions. So, the elements the compounds which give hydrogen ions kudukudo. So, that is called as acid. So, this is the Arrhenius concept. And Arrhenius concept, it is not in equilibrium nature. Arrhenius concept, it is only for it's a dissociation. Simply we say it's a dissociation nature, that's it. Right. In Arrhenius, the hydrogen ion, you see the hydrogen ion is aqueous solution, is highly hydrated and usually represented as H3O plus. So if we write the water molecules H2O, that H2O split into H plus and OH minus ions, that's all. The H plus is called hydrogen ion concentration and OH minus is called hydroxide ion. That H plus, it's highly hydrated, so we mentioned it's like it's H plus, it's joined with another H2O water molecule. Another water molecule, it's give H3O plus. It's a hydronium ion. So, hydronium ion. So, that hydronium ion is it is also same. H plus and H3O plus. Yes, H3 and H plus and H3O plus, both of them is the same one, right? Okay, students, listen. And the H plus ion in aqueous solution is highly hydrated and usually we represented as a H3O plus, the simplest hydrated of proton. So H3O plus, we should write H and H2O plus. We use both H plus and H3O plus to mean the same. Similarly, the base is a substance that dissociates, give the hydroxyl ion in water. For example, calcium hydroxide. The calcium hydroxide, it dissolved in water, it's given to calcium ions and hydroxide ions. Calcium ions and hydroxide ions. So this is, it produced, why the calcium hydroxide we mentioned it's a base? Because it produces hydroxide ions, right? HCl, why we are calling HCl is an acid? Because it produces H plus ions. That's it. So this is the Arrhenius concept. And okay, the limitation of Arrhenius concept. Limitation. I mean failure of Arrhenius concept. Arrhenius concept, it's a dissociation of electrolytes. Dissociation of water molecule. Dissociation of electrolytes or salts in the water molecules. In an electrolyte, it is dissolved in water molecules and it produced some electrolyte, some ions like H3O plus and OH minus. Using this concept, Arrhenius concept, we explain H plus, I mean acid and base. So using with only the water molecules. Now, I mean your H2O solvent, universal solvent. So not other than, rather than non-polar solvents like organic solvents, non-aqueous solvents like acetone, tetrahydrofuran. So these kind of solvents using, I mean the replacing instead of water molecules. Even one salt or one water or one acid dissolved in a water and it producing two kind H3O plus and another ion, I mean another anion. So this is the Arrhenius concept. Arrhenius concept is, it simply we say in an electrolyte it is dissolved in water and it produces some ions. That ions consist that ions is the both H3O plus or OH minus ions. If the ions are the producing, if the producing ions is H plus H3O plus, so that is the acidic nature. If the OH minus ion is produced, that is called basic in nature. Right. Now, the limitation concept. So, we replace the solvent. We replace the solvent of water, H2O, and we replace the aqueous solvents like acetone and tetrahydrofuran. In this theory, does not account for the basicity of the substance like ammonia, which do not possess hydroxyl group. For example, you see, ammonia is the base. Ammonia is the basic in nature. But, so this ammonia, it does not have any OH group, or it does not have any OH group, or does not produce OH group. So it does not giving to OH group in react with this molecules. I mean this concept, this arginine concept. So this kind of process, and also boron trifluoride BF3. It's a acidic, Lewis acidic. So this kind of substance, only the arginine concept, it is successible for polar solvent, dissolving in polar solvents. Right. The next, the failure, I mean the limitation of arginine concept, or the inability to explain of arginine concept, we introduced new concept that is called Lowry-Bronsted theory. So the Lowry-Bronsted concept theory, the theory is a proton theory. That theory is proton theory. You see, what is this theory? According to their concept of an acid, is defined as a substance that has the tendency to donate a proton to the another substance, and the base is a substance that has the tendency to accept a proton from the substance. In other words, acid is an acid is a proton donor, and the base is a proton acceptor. What is mean by proton? Proton is nothing but it's a H plus or H3O plus, whatever may be. But H plus is a proton. You see. So this is the Lowry-Bronsted theory. In a HCl, it is dissolved in polar solvent like water. It produces H3O plus hydronium ion and Cl minus ion. So the same way ammonia. I mean, in ammonia, it is not explained in a previous theory, but this theory, ammonia, it is dissolved in water. It produced ammonium ion and OH minus ion. So this is the, when ammonia is dissolved in water, it accepts a proton from water, accepts a proton. So ammonia accepts one proton. So water molecule, it can dissociate into H plus and OH minus. The same way H plus and OH minus. The H plus is a proton. So proton it accepted by ammonia. So here proton is accepted by HCl. So HCl, it split into H plus and Cl minus. Okay, the H plus, it is received by H2O molecules. Right, proton acceptor. So which one is the proton acceptor? In both of two components, two reactant is there. One is hydrogen chloride, HCl, another one is water. So HCl, in a HCl, which one? HCl is the acid or base? So based on the Lowry-Bronsted theory, an acid means proton donor. Which one is a proton donor? Here HCl is the proton donor. So HCl is called acid. So H2O, here H2O, it is received proton from acid. So that is meant by base in nature. H2O, here H2O is the base, proton acceptor. HCl, proton donor. Next you see ammonia. So the ammonia, so water molecule, it can be split into H plus and OH minus. Ammonia, it accepts hydrogen H plus ions from water molecule. So here water molecule is a electron donor. Proton donor. Proton donor. Ammonia is a proton acceptor. So in first reaction, H2O is a base in nature, basic nature. Second reaction, H2O is a acidic nature. From these two conditions, water molecule H2O is a amphoteric nature. That is mean by, what is mean by amphoteric? Amphoteric is a both acidic and basic nature. So it prove acidic nature, or also it prove basic nature also, right? So here you see H2O in this reaction, simply we say Lowry-Bronsted theory, proton donor is a acid, proton acceptor is a base. That's it, right? Next, Lowry-Bronsted proton theory, you see the same way here. So in this concept, in a HCl, H plus in Cl minus, H plus accept. So this is proton, I mean first it is proton donor, so that is called, this is acid 1. Proton acceptor means base. You see, so the H plus ions, it is accepted by water molecules and it produced H3O plus. So this is also in a forward reaction. Students, listen carefully once again I repeat it, listen carefully. You see, in a forward reaction, so this is the equilibrium nature. In a forward reaction, HCl and H2O. HCl, it split into H plus and Cl minus. H2O, HCl, it donating proton from itself. So the water molecule accept proton. So the proton donor is called acid, proton acceptor is called base, right? So it forms H3O plus and Cl minus. H3O plus and Cl minus. Again, it's reverse back. It's a reverse reaction. So this in a reverse reaction, these two products is a these two product as a reactants. In a H3O plus and Cl minus. In a reverse reaction, you see H3O plus, it lose H plus ions from itself and it change into H2O. And also Cl minus, it accept that losing H plus ions, it change into HCl. In a reverse back, so H3 hydronium ion, it's a proton donor, it's behave like a, again it's a acid. Cl minus, it accept proton, it's called base. In a reactant side, in a forward reaction, HCl is acid, H2O is a base. In a reverse reaction, hydronium ion is acid, chloride ion is a base. So in these two acid and 2 base is formed. So that 2 acid, 2 base means, you see, HCl, it's a acid donor. So this is for acid 1. In a forward reaction, acid 1. Reverse reaction means proton donor, it's a acid 2. So this is acid 2. In forward reaction, H2O, it's a proton acceptor. It's a base 1 or base 2. Base 1 or base 2. So once again, you see H3O plus donates a proton to Cl minus to form HCl. The product also behave as a acid and base. So acid 1, the base 1. So this is base 1 coming from HCl. So that's why, so we call this is a base. Base 1. Acid 1 will produce base 1. Right. Next, and also the products have also behave as acid and base. In general, Lowry-Bronsted acid base reaction is represented as acid 1 base 2, acid 2 base 2 base 1. The species that remains after the donation of proton is a base 1. So base 1 H2O. Yes, remind the donation of proton is a base and called conjugate base of the Bronsted acid, acid 1. Yes. So from the acid 1, it donate 1 proton to the another donated proton from itself. So this is the acid one, and after the donating or losing the H plus ions, it is formed as Cl minus ion. This is proton acceptor. Proton acceptor. It's a base of HCl. The base produced from HCl. So that's why we called conjugate base. You see, the conjugate base. HCl is an acid, which is the conjugate base of HCl. So that is meant by Cl minus. And H2O is the base. H2O is the base 2. And it's formed proton, it it's donate proton acceptor from in a reactant side. In a product side, it's a proton donor. It's behaved like a proton donor. So this is the base conjugate. This conjugate acid of this base is called H3O plus. எப்படி சொல்லலாம் அப்படின்னா HCl is a acid னு சொல்றோம். அப்ப acid will produce ஒரு base. அப்ப acid produce பண்ண அந்த பேஸுக்கு பேர் வந்து conjugate base. அதே மாதிரி base H2O is a base. So base will produce one acid. So that is called conjugate acid. அவ்வளவுதான் சிம்பிளா. Right. Okay. HCl and Cl minus H2O and H3O plus are the two conjugate acid base pairs. Acid base pairs. Simply we say, students listen, simply we say HCl will produce Cl minus, H2O will produce H3O plus. So here it's a base, this is also base. So this is also basic nature, and this is also basic nature. So both of these two is base, and this is for acid, and this is also acid. This acid will produce this acid. This acid will produce this base, and this base will produce this acid, and this base will produce this acid. Okay, right. So idhula enna theriyana H3O HCl will produce Cl minus. HCl is an acid, Cl minus is a base. So HCl is a simple acid. The conjugate base of the HCl acid means Cl minus. H2O is a base. H2O it produced one acid. So conjugate base of the conjugate acid of the H2O base means H3O plus. Okay, right. I mean, இது யாராரு எதை கொடுக்குறாங்களோ அதை வச்சு நம்ம ஈஸியா நம்ம அதை எக்ஸ்பிளைன் பண்ணலாம். ஓகே, ரைட். Limitation of the Lowry-Bronsted theory. Yes, limitation. Failures. Substances like boron trifluoride, aluminum chloride that do not donate protons are known as behave as acids. So they don't have any protons like hydrogen ions. In a HCl in a HCl, H2SO4, H3PO4 and HNO3. So these are all acids. Why these are compounds are called acid means they have H plus hydrogen ions. They have hydrogen ions. So according to the Lowry-Bronsted theory, so these ions will donate protons. But boron trifluoride, BF3, boron trifluoride, aluminum chloride, they don't have hydrogen ions. But these two components or these two compounds also called acids. How it's possible? So this is the inability to explain Lowry-Bronsted theory. So we need one more theory. That theory is called Lewis concept. Lewis concept. Another one theory will be formed. That Lewis concept. According to the Lewis concept, an acid is a species that accept electron pair. An acid is the electron pair, while base is a species that donates electron pair. So this theory it's entirely opposite for Lowry-Bronsted theory. Lowry-Bronsted theory explained only for proton theory. Lewis concept is called as electron theory. So electron theory means the same meaning, the reaction is the same, but the concept is he took electrons, the pair of electrons, but Lowry-Bronsted theory, they took proton concept. Okay, now you see, so that electron pair theory, so electron pair accept, if any of the compound accept electron pair or receive electron pair, that is Lewis acid. If any of the compound donate electron pair is called Lewis base. You see, the simple one shortcut, you understand one simple concept for error law. Each and every students, you just remember that word error law. What is meant by error law? Electron receiver is a Lewis acid. Electron receiver is a Lewis acid. This is the simple concept. So, which any kind of the substance which receive pair of electrons from outerwards or from other elements or from other compounds, so that is called as Lewis acid. Accept an electron, pair of electron. So, whichever the compound will donate a pair of electron is called Lewis base. You see here boron trifluoride and ammonia. So, two compound is there. Boron trifluoride is there and ammonia is there. Ammonia, nitrogen, the valence of nitrogen is 5. Hydrogen, 3 hydrogen only, it's making bond formation with nitrogen. So, reason octet rule. So, reason is octet rule and also according to the octet rule, so 8 electrons is there. So, ammonia it's NS3. So, remaining, so 3 electrons only using for nitrogen. 3 electron using with bond formation, making the bond formation with hydrogen atom. So, remaining 2 electrons, it's kept lone pair of electrons. In a ammonia molecule, nitrogen 3 electrons only using with bond formation, making bond formation with hydrogen. So, remaining 2 lone pair of electrons. The 2 lone pair of electrons, it's kept is kept over in a nitrogen. Right. Next, the boron trifluoride. Boron, you see, boron atomic number 5. It's 3. So that's meant by valency 2s2 2p1. So this is the electronic configuration 2s2 2p1. So boron trifluoride, boron it's making bond formation with ammonia. Ammonia, that means boron it's created. You see, and Lewis acid is a positive ion. Consider the reaction boron trifluoride and ammonia. So boron it received 2 electron from itself and also boron will produce empty d orbitals like next. So 2s 2p. So this 2 empty orbitals is there, p orbitals. Here p orbital is there. So it's making coordinate covalent bonds. Nitrogen, ammonia. In ammonia, nitrogen and the bond தேவையான 2 எலக்ட்ரானுமே நைட்ரஜனே கொடுக்குது. So nitrogen it donate the lone pair of electron from itself. So it's making coordinate covalent bond. So in this concept it's adduct. In this concept boron trifluoride behaves like a Lewis acid. Ammonia behaves like a Lewis base. Right. Boron has vacant 2p orbitals to accept lone pair of electrons from donated by ammonia to form new coordinate covalent bonds. You see. So the 2 vacant orbitals, these 2 vacant orbitals, that's 2p vacant orbital is there. That 2p vacant orbitals, it's filled by the ammonia lone pair of electrons. Right. So now, and also our fifth lesson coordination chemistry, we study very well about ligands. So the ligands, it's a ammonia to form new coordinate covalent bond. We have already learned that coordination compounds, the ligand act as a Lewis base. Because ligand always donate pair of electrons. Ligand always donate pair of electrons, and metal ion, central metal ion accept pair of electrons. So behaves like a ligands behave like a Lewis acid, and central metal atoms behaves like a Lewis base. Right. Next, Lewis acid and Lewis bases. What is mean by difference between Lewis acid and Lewis base? Lewis acid, electron deficient molecules. That's why electron received. Electron deficient molecules, and Lewis base, molecules which one or more lone pair of electrons. Electron rich, electron deficient, electron sufficient molecules. Yeah, all the metal ions, it's a electropositivity nature. So due to the electropositivity nature, it receive electrons from outer source. So all the anions means it's getting more number of electrons. Molecules that contain polar and double bond examples. Polar compounds or double bond compounds. C double bond O. This is the carbon dioxide structure, and this carbon dioxide will change into C triple bond minus and C single bond plus also. So positive nature also. So this is the polar nature. So the polar nature of molecules, double bond molecules such as alkenes type of olefin compounds, C double bond, C triple bond type of compounds. Molecules in which the central atom can expand in octet due to availability of empty d orbitals. Empty d orbitals or empty p orbitals, whatever may be available. Octet rule, which is fulfilled by octet rule. All metal oxides behaves like a Lewis base. Carbonium ion, carbanion. So carbanion behaves like a Lewis base. Carbonium ion, it's behave like a Lewis acid. Right. You see, next, strength of acid and strength of bases. Okay, according to now in this session we explained how many 3 theories is there. So what's the 3 theories? So you see, students. So three theory we explained it. Important formula. One is a Arrhenius theory. Arrhenius theory. So that Arrhenius theory means to give H plus ions in water, to give OH minus ions in water. So we conclude. So what is mean by acid and what is mean by base? According to the Lowry-Bronsted theory, it donates a proton and it accepts a proton. According to the Lewis theory, it accepts a pair of electrons, donates a pair of electrons. That's it. So this theory explained acid, which one is the acid and which one is the base. Simply we say hydrogen ion concentration will get more concentration, so that such kind of compounds is called acids. Hydroxide ion concentration, which get more number of hydroxide ion concentration, so that compounds behaves like a base. Okay, thank you so much, my dear students. We discussed in further topics in next session onwards.